been able to keep up with all your schoolwork and regular work and taking care of families, and you've got a lot you're doing, I know.
Is your husband work from home?
Yep. There he is. Probably see him a lot behind me. So he has some earpods in though, that are the noise canceling ones, so he doesn't hear us. Which is good. Then he can do his work.
What does he do? Is that IT or something?
No, he's an attorney. So,
Oh, okay.
yeah. All right, well, I'd say we get started here. More stuff today. I'm trying to get through 6.5 and 6.6 today. And we are getting so close to the end of the semester. 6.8 is our last section, and so we are almost there. So next time we'll kind of finish up pretty much all new content that we're going to be doing, and then all of next week we'll just spend time reviewing for the final exam, because remember, the final exam is going to be comprehensive, so everything from Module 1 through Module 6 is going to be on there. So, any questions about the final exam or anything like that?
Yeah, is that going to be like a PDF that we download, scan, and turn in so we can show our work? Or is that going to be like...
Nope, it's going to really look similar to your Canvas quizzes.
How much time will we have?
So you'll have 2 hours.
Okay, good.
Mm-hmm. And I think there's like 30 questions on there. And that should be plenty of time for you to be able to get that done. And then you should know your score, right? Right at the end of it, it'll tell you what your score is. It won't let you go in and view the questions that you missed until after the close date. But you can go, but you can see what score you got. You just won't know which ones you missed until maybe a couple of days later, because there's going to be a window of time that it's going to be open from. I think it's May 4th, 5th, and 6th are the days, and so you're just going to pick like a 2-hour time block on one of those 3 days that you'll go on and you'll get that test taken. And like I said, it's going to look really similar to those Canvas quizzes that you've taken all semester long, and so it'll be kind of like that. So
Do we have to do an e-portfolio for this class?
no, you don't. Nope. 1010 is the first math class that you have to do an e-portfolio for. So 980, you don't have to. A lot of people are very excited about that because yeah, they definitely are some work, but they're good. I think they offer some really good things. So, but yeah, what was I going to say? Can't remember now. But something about your final. Oh yeah, I will. So I'll go back in though and make sure that, like on the Module 4 quiz, I went back in and checked the ones that it said you'd missed, because sometimes it was just weird with the graphing and you didn't really miss it, and so I gave you those points back on there. And I'll do the same thing on this final exam. Just make sure, the ones that it says you miss, I'll go back in and look at individually and make sure, that it shouldn't have been marked correct or something. And, maybe just because of, you put an extra space or something weird like that in, that it marked it wrong. So, okay. But yeah, that's kind of how the final exam's going to be. It's going to be that way. Okay. All right. Well, let's look at 6.5 first of all. And we're going to be talking about base E and something called the natural logarithm. Okay, so we talked about things in base 10, right, and how that's a common logarithm. That's what we talked about in 6.4. So now we're going to be talking about these natural logarithms, and they're always in base E. So what I want you to do first of all is I want you to locate on your calculator, so get your calculator out, and you should see a button that says, it says ln, but a lot of people think it looks like it says in, but that's actually a lowercase l, so ln, all right, and it should be somewhere close to your log button. Usually they're next door to each other, but it, like I said, it might look a little different. It might say like the natural log of x. It might, I'm trying to think if there's anything else that I might say. I think I might just say one of those. And the other button that I want you to look for is something that says e to the x power. And oftentimes it's connected to the natural log button. It's like the shift, you know, your shift button that you have to press to hit it. Now be careful, because there are on some calculators just a button that just says E, and that's not the same thing as e to the x. So E just means e to the first power. And if you go in and you try and put that into your calculator, like, so try that on, like, so find that natural log button, or sorry, the E button, and put in e to the first power. And when you do that, you should get this long decimal that's like 2.7182818, blah, 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 right? And it keeps going and going and going. And it goes on forever. It's never ending. It's non-repeating. It's kind of like pi in that way, where it's this long irrational number, okay? And so this is the base that we're going to be talking about. And you're like, that seems like a really weird base. Why would we use this base that's like, you know, 2.718281, you know, like, it just seems weird. But it's because, so they're called natural logarithms, right? Because they are things that are occurring in nature, kind of like, you know, some growth and decay. And we'll deal with some story problems that deal with growth and decay in the next couple of sections. And so you can kind of see what we mean by it, okay? But like things that are growing in nature, like populations, either, you know, like human populations, but maybe even populations of, you know, different types of animals or fish or, you know, something like that. They grow at this rate that, you know, always seems to be close to this 2.7 something, something, something. So we are going to approximate E in this class to be 2.72. Just like with pi, we use 3.14. All right, we're going to use 2.72 as kind of our approximate for E in this class. Okay. Let's see. Did anybody not, if you didn't find one of these buttons, will you raise your hand? On your calculator, should be able to find those somewhere. A lot of what we're going to be doing today is going to be involving these buttons. Okay. So, Emery, can you show me what calculator you have? Did you find it or no?
Yeah, I have this one. I found it.
Oh, you did? Okay, cool. Awesome. Okay, anybody else? All right, well, let's do a couple of problems then, some examples of what we're going to be doing here. So want to just make sure, first of all, you remember that natural log, okay, natural logs are always, okay, always in base E. Okay, they cannot be in any other base. With regular logs, right, we see that those can be in different bases, like we'd have log base 2 or log base 5, or if it just said log, then that's log base 10. But natural logs are always in base E. So if I have something like this, and when I write natural log, I do my L that way, a cursive L, just so it doesn't look like an I or you know, or a 1 or something like that. Okay, so the natural log base E of e to the third power. Okay, I want to kind of look at this and see what this would be. So here this is in log form, but remember, if we wanted to change this to exponential form, right, we'd say, maybe I'll put this kind of equal to y. Right, but we said, okay, we do e to this power equals all of this, right? So that means it's going to be e to the y power equals e to the third. So that means that y equals 3, right? So the base, or sorry, the exponent, right? Remember, whenever you're finding logarithms, right, when you're taking a logarithm, this y that you're solving for is what is the exponent on it, okay? And so in order to make those equal, we'll say, okay, y has to be 3 here, right? But these are always in base E. So let me just show you one other thing. Usually they won't show the base E there. So they'll just say something like the natural log of, you know, let's do e to the 0 power, something. All right. Well, remember, right, this is in base E, and it's not, I'm going to just put it in a different color to help remind you that they might not show it to you, but you got to remember it's there, right? And so again, if we try to rewrite this, right, we're saying e to the y power, right, so this to this power equals e to the 0, okay? So y equals 0, but what is e to the 0 power? What's anything to the 0 power? Anybody remember? What's anything raised to a 0 power? And just write it in the chat. What was that?
Is it just 1?
Yeah, it's 1. Okay, anything raised to a 0 power is 1. All right, so basically when you see this, you know, natural log e of e, so let me see. So that's going to basically just be 1, but let me look at one other one here. If we say the natural log of e, base e of e, right, this is really saying e to the y power equals e to the first power. So here we get, you know, e to the first power on that. So what I want you to see is if this kind of like cancels each other out. If you have the log base e of e, those things are going to kind of cancel each other out. And we'll see those more like in 6.6. We'll kind of come back to this idea and kind of help you see what I mean by that and why that is important to remember. This, you know, natural log of e is just really 1 is your answer there. All right, let's do some on your calculator. Okay, so like I said, a lot of these things are going to be just things that you're going to be putting into your calculator. So let's try a few of those. So for example 1, let's do the natural log of 55. Okay, so in some calculators you'll have to put 55 and then press the natural log button. Other calculators, you'll press the natural log and it might have it in parentheses. All right, and then you'll press equal. But you should come up with, and on this one, they're going to want you to round to 4 decimal places whenever we're dealing with logs. Round to 4 decimal places. So on this one, we'd have 4.0073. All right, so I want you to try that on your calculator and see if that's what you come up with, if you rounded to 4 decimal places. Okay, raise your hand if you were able to get that. Anybody know where that raise hand button is? Remember, you got to go up to the top and open up that participants box so you can see everybody's names, and then you can click on yours. Jose, do you see how to get that? Emery, Angel, what's that?
Yeah, I saw how you got that.
You got it? Okay.
Yeah.
Angel, were you able to get that?
Yeah, I get it.
Okay, all right. You just didn't raise your hand, so I just wasn't sure if you understood how to do it. Okay, now I want you guys to see, what if you did log of 55? Do you think you'll get the same answer, or is it going to be a different answer? So try that on your calculator. What happens there if you just do log of 55? And again, I want you to round this to 4 decimal places, so I want you to put in the chat, right, what did you come up with for log of 55? Don't press enter quite yet. Okay, but I want you to tell me what you come up with. So get it put into the chat. Don't press enter yet. Let's give everybody a chance to try and do it. Okay, 3, 2, 1, hit enter. Okay, awesome. All right, so we definitely come up with something different. All right, so 1.7404, that's what you guys are saying you came up with. Okay, why would these be different? Is there anybody that could tell us in words? Why would you get different answers there? Anybody willing to take a stab at it? Why are those different?
Doesn't log have a base of 10
Mm-hmm.
instead of ln have a base of like e?
Yeah. So since they're different bases, right, remember what this is really saying to us, right? We kind of did this a little bit last time where we kind of played around with it. So this one's saying e to the what power, right, is going to give me 55, right? And so, I mean, try on your calculator, even if you put e to the 4th power, right? It was a little bit more than 4, but try that on your calculator. Put e to the 4th power, right? And what do you come up with there? I came up with 54.598 blah, 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 right? So it's pretty close to 55, right? So remember, this is the power. We're saying e raised to this power gives us something close to 55, right? Where on the other one, we're saying 10 raised to what power is going to give me 55. Right, so we have a different base, so we're doing, 10 to what power? Well, 10 to the you know, almost 2 power. Maybe if you put it as 1.7 power, right, you're going to get something kind of close to 55. Right, so just make sure you're understanding like what this means, not just, okay, can I put it in my calculator, but let's make sense of what it is you're finding, right? Because in your next math classes and in some science classes, you're going to be using logarithms. And so it's important to understand not just how to find them, but what they are, right? What you're really doing there. Okay, let's look at a couple others here. So how about this one? Example 2. So what if I said find the natural log of 0.4? Again, round to 4 decimal places. Okay, so I want you to put what answer you got into the chat box. Don't press enter quite yet. Put that in. What did you come up with for natural log of 0.4? Okay, go ahead and press enter. Let's see what you got. Okay, it looks like most of you are saying negative 0.9163, right? Because we needed to round that last decimal because that 2 rounded up, right? So, but I want to talk about why is this negative, right? Because, you know, before we came out with some positive answers here, but think about what we're taking the natural log of. So if I'm thinking of e to the what power is 0.4. So this is a fraction, right? So remember when we have like any base raised to a negative exponent, right? That's going to give us a fraction, right? So it's important to like kind of see that the reason why this is negative is because we're trying to equal out to be something that's a number between 1 and 10, right? It's a fraction answer, right? So that's why that makes sense that that one's negative on that. Okay. All right, let's look at just a couple others here. What about, so example 3. So now let's use your E button again on this, okay? And I want you to, again, you're going to round to 4 decimal places. Okay, but I want you to find e to the negative 1.5 power. Right? So I want to make sure you know how to get that in your calculator as a negative exponent. And again, round to 4 decimal places on that. And because we're raising it to a negative exponent, I'm expecting that my answer is going to be between 0 and 1, right? Because it's got to be that fraction, right? So I came up with 0.2231. Wait a minute. Yeah, 2231. Is that what you guys came up with?
Yes.
Okay. Anything different there? Everybody figured out? Sometimes on some of your calculators you might have to put parentheses around that if it's raised to the power and it's a negative number. All right, just make sure you know how to work with those negative exponents. Okay. All right, the next thing that we're going to talk about is just doing some graphing with these natural logs also. Okay, so example 4. Let's graph y equals e to the x power. All right, so this is an exponential function. And remember, e is a number that is, e is approximately 2.72. So we're basically, taking about 3 and raising it to the x power. So this is exponential growth. And remember, like we talked about before, we said something that has exponential growth to it would have this kind of a look to the graph. Okay, but let's go through and find some points on this, right? So, and graph these out. So we're going to just pick some x's and figure out what our y's would be on this. So maybe let's just pick some of our ones that we kept, keep doing. Like let's do -2, -1, 0, 1, and 2. All right, so I want you to go through and fill in this chart. All right. So. And then make sure you simplify it. You want to, just on this one, just round it to 1 decimal place so we don't have so much to write out. Okay, so e to the -2 power, you should have come up with 0.1. Right? E to the -1 power, it's about 0.4. E to the 0 power, anything raised to the 0 power is 1. And then e to the first power, right, on that one, we're just going to say that's 2.7. So it's kind of 2.72, but we're just going to round it to the nearest tenth, right, just to make it easier. And then e to the second power would be about 7.4. Okay. Everybody come up with those for your y's? Or do you have any questions about how we got there? Just unmute yourself and ask if you do. Okay. And I so appreciate you guys. You guys haven't given up and you're still coming and you're just, trying to, get through this. We're so close to being done. There's some of your classmates that are kind of giving up and, and I just feel so bad because I'm like, you're so close to being done. So please don't give up. Okay. Let me help you with anything that I can help you with. So you can end this successfully. Okay. So I want to make sure you can do. All right. So then if we plot this, all right, so over -2 up 0.1, so that's going to be about here, over -1 up 0.4, over 0 up 1, over 1 up 2.7, so maybe about there, and over 2 up 7.4. So again, this is just kind of a little rough sketch of this, all right? And sometimes on your homework, it might just give you like 4 different graphs to choose from. And I really want you to think about what you know about them, right? We knew this was exponential growth, so I knew it was going to be looking this way, where there might be, they might all be going different directions. And so you could just kind of work smart and go, oh, this is an exponential growth. It's got to be this one. That's the only one that follows that look, right, of exponential growth. All right, so that's e to the x power, right? Now, what if I wanted you to graph the natural log of x. Okay, let's do that one next. So example 5. Let's graph the natural log. Y equals the natural log of x. Okay, but remember, with any kind of logs, right, I'm going to write in what that base is if it's not shown, right? This is really a base e that's there. And then you're always going to want to change that to exponential form. It's going to make graphing these a lot easier. Okay, so I'm going to write that here. So change to exponential. Ooh. I got a little bit carried away there. Okay, so exponential form. So that means we're going to do e to the y power equals x. Right? So e to the y power equals x. And then when you're picking, right, when you're trying to fill in your chart, we're not picking x's this time. You're going to be picking y's, right? So then pick y's and solve for x. Okay, so let's do that. Make our little handy dandy little chart over here. So I still have my x and then my y, but I'm going to be putting in some values for y this time. All right, and again, usually using those same ones, these are usually pretty good ones to pick. Don't have to pick these, but want ones that are close to 0 and ones that will stay on our graph. So, okay, but then remember on this, let's see, I'm going to try and write these out. I might have to put a little bit of work here. All right, just in a little different color. So I'm going to be doing e to the -2 power equals x. All right, e to the -2. All right, and we actually found that up here, right? What that was. All right, e to the -2 was 0.1. All right, and I want you to see something that happens here. There's like kind of a cool pattern that you're going to notice happening. So this one's going to say e to the -1, right? And we found e to the -1 to be 0.4. Then e to the 0 is just 1. E to the first is 2.7. And e to the second, right, again, we found it up here, is about 7.4. Okay. So what do you notice on here with our, so we've got our x's and y's, right, and our x's and y's here. What do you guys notice is happening with this graph with our x's and y's?
They're flipped.
Yeah, they're just being switched, right? And that happens because these guys are inverses of each other. Right? So whenever you graph a function and then graph its inverse, it's not just with logs, but with any graph, right? Then their x and y's will just be switched when they're inverses of each other, right? So we've got 0.1 and then -2, right? So they're just switched. Oops, that point looks like a negative. So let me fix that. Right, and then 0.4, and -1, 1, 0, 2.71, and then 7.42, right? So they're just switched. Our x's and y's are just being switched. Okay, so what does that do to our graph? Well, let's take a look at it here and see what happens this time. All right, so when I graph it on here, All right, so I'll do it in blue this time so we can kind of see that. So we're going to go over 0.1 down 2. So that kind of looks like it's on the x-axis, but it's not. It's just really close to it. Okay, and then, whoops, what happened there? Yeah, and then over 0.4 down 1, so about there. Over 1, 0 is there. Over 2.7, up 1. And over 7.4, up 2. All right, so again, so our graph is kind of looking like this. All right, so you got to make sure that you understand that there are some asymptotes on some of these. Let me shut this door just a second. Husband had a work call he had to take. Hope he doesn't have to be in here for it, but so there's an asymptote, right, on both of these. And on some of your homework, it might ask about these asymptotes. So when it's exponential growth, let me go back down so we can look at this one again. When it's exponential growth, we're always going to have a horizontal line is going to be our asymptote. Right? And on this one, it's the x-axis. Right? Or you could call it y equals 0. It's the same thing. This line right here, this dotted green line, right, is an asymptote on the x-axis, or the line y equals 0. Right? And so there's always going to be exponential growth always has horizontal asymptotes. Right? Where you're going to have this horizontal line. Where if we're looking at our other one, right, so it kind of looks like this log is just kind of, it looks like it's going to, you know, have an asymptote here, but it doesn't. It keeps going up and out, but it just is going up really, really small amount every time. So it almost looks like it's not moving. But there is an asymptote. Oopsie. There is an asymptote here. Right? So it's getting really, really close to the y-axis, but it's never going to touch it. Okay, and the y-axis is also has the name of x equals 0. Right? So these are always going to have, right? So when you have your log, your exponential or your logarithmic growth, right, has a vertical asymptote. Okay, so it might ask where those asymptotes are on your homework. So I just want to make sure you're seeing it's that you know, line that it's getting really, really close to, but it's never going to touch it. Okay, it's never going to get quite there. It just gets really, really, really close. Okay. Does everybody understand that? What asymptotes are, or what questions do you have about asymptotes? I know it's a weird sounding name. Some people are like, what? Sounds so crazy.
Is there still an asymptote in exponential decay?
Yeah, there is. And so with exponential decay, remember that let's look at one of those. Right, so we said exponential decay would be, it kind of comes down from the top this way, right? And then it still is getting really, really close to the y-axis. So it's also going to have a horizontal asymptote. So our exponential growth or decay, right, always have horizontal asymptotes, where the logarithmic growth or logarithmic decay, say both of them, have vertical asymptotes. Oops. vertical asymptotes. Rewrite that. Because remember, logarithmic growth, well, this is logarithmic growth right here, right? Let's see, so it kind of looks like this. And logarithmic decay, right? So this is growing that way, where the decay one, it's going to be going, you know, like as you're looking at it from left to right, it's going to be going down, right? So that means it's going to be kind of like, let's see how I want to draw it. I'm thinking here. Kind of like this, because it just looks kind of weird, but it's going to be kind of coming out this way and then going down. All right, but our asymptotes, maybe I'll kind of show them here. All right, so that's like this. Like this. It's getting close to a line there. Where we've got horizontal ones on both of these. Okay, hopefully that kind of helps to think about these. Let's do one more graphing one, because all the ones we've talked about so far, all of our asymptotes have been like either the x-axis, the y-axis, but they don't have to be like the x or y-axis. They could be a different line. Okay, so let's see where we're at. Example 6. Okay, so this time let's graph. Y equals the natural log of x plus 2. So notice that x plus 2 is in parentheses. We're finding the natural log of all of that, right? But again, remember when we're dealing with logs, we first want to change that to exponential form. All right, so I'll do e to the y power equals that. All right, so e to the y power equals x plus 2. Right, and then we want to solve this for x. All right, we want to get x by itself because that will make it a lot easier for us to do the graphing of it. So let's subtract the 2 over. So I get e to the y power minus 2 equals x. Okay, so this is the same thing. It means the same thing as this natural log base e of x plus 2. But it's just in a form that's going to be easier for us to graph it. All right, so that's what we want to use here on this. So let's try this. So again, we're going to make our little chart here. All right, and remember we're going to pick y's and figure out what our x's are going to be on this. All right, so on this one, we want to pick our y's. All right, so when we do that, let's do, well, I guess we can kind of just do some of the same ones. Let's do -1, 0, and 1 first of all, and kind of see where we end up with there. And then we might want to choose some other ones. And I kind of want to show you what, what are going to be good ones to pick. But sometimes you kind of have to look at what we have first of all and then go from there if you're not sure which ones to pick. All right, so I'm doing e to the -1 power, and then whatever that is, I'm going to subtract 2 off of that. Okay, and so just do that on your calculator. E to the -1 minus 2. And make sure you don't put that minus 2 up in the exponent, right? You find e to the -1, then take that answer and subtract 2. Right? So you should get something like -1.6. So check first of all and see if that's what you guys got. Let me know if you're not getting that. You won't be alone. Somebody else in the class might be having the same issue as you. Okay, let's try a couple more. So e to the 0 power, then minus 2, right? So we're doing 1, and then minus 2 is negative 1. And then e to the first power, minus 2. E to the first power, right, minus 2, that's going to be like the 2.72, right? And then you're going to minus the 2 off of that. So it should be somewhere around 0.72. So I'll just say 0.7, just round it to 1 decimal place. Okay. Is everybody okay seeing how we came up with these numbers here? You guys are so quiet. I cannot tell what you're getting and what you're not getting. I really need you to speak up and let me know.
Are we going to be asked to graph these on the homework?
So on the homework, like I said, there might be some, like some of these are going to be really, like you can't find 2 whole number answers on some of these to really figure it out. So oftentimes they'll give you like a multiple choice and they'll give you 4 different graphs to choose from. But on some of them where you can, you know, get 2 points that have whole numbers to them, they will have you graph them out.
Okay, so like the ones we were doing on like last time's homework, there might be, you can graph those, but usually these are just multiple choice.
Yeah, I think there's maybe one or, well, there's the exponential ones on here that they have you graph. I'm trying to remember if on the homework if they have you graph any of the natural log ones or if they're all multiple choice. But yeah, if you have any issues with, you know, graphing those on there, let me know. Okay. But if we look at just these 3 points, we can kind of tell the shape of what it's looking like, but we might not be able to tell where the asymptote is. And that's one of the things, even when it has you pick like the multiple choice, it might have a part B and say, where's the asymptote, right? And so we want to make sure we'd be able to tell what that is. So let's go ahead and like just plot these 3 points though, and then we'll see if we need to do a few more. So over negative 1.6 down 1, over negative 1 up 0, over 0.7, right, up 1. And so we can kind of see the shape is kind of like this, but it might be kind of unclear where that asymptote is. So maybe let's choose negative 2 and see what's happening. So e to the second power minus 2, right? So e to the second, and then minus 2. Let's see, oh, whoops, e to the negative 2 I meant to put. I only put positive 2. All right, e to the negative 2. So it's giving you like negative 1.9. So do you see how it's getting closer and closer to negative 2? And as you put numbers in there, right, if you put e to the negative 3, e to the negative 4, e to the negative 5, they're never going to get bigger than or smaller, I should say, than negative 2, right? So our asymptote is here at negative 2. So the easy way to tell where your asymptote is look at our original equation, right? And whatever makes this 0 is where our asymptote is going to be, right? So at negative 2. So x equals negative 2. So if I put negative 2 in there, that makes that 0, okay? And so that's where our asymptote is. Okay? And then it's just going to be getting closer and closer and closer to that, and then going up and out like that. Okay? All right, questions on that one? Everybody see how we can figure out where that asymptote is? And look at it. You can see it in the equation there. Or if you kept putting y's in, right, that were smaller and smaller and smaller, we'd see that we'd never get anything over -2, or nothing to the left, I should say, of -2. It's getting really, really close to it, but never crossing that line. Okay, guys, feeling all right with that? All right, let's take a little 5-minute break right here, and then we'll come back and do 6.6. Okay, get up, stretch, get a drink, do something. Okay. Get a snack. I'll leave it there. Can you guys tell that I was in the sun yesterday? I actually got a little burnt. I was only out there. I took a little walk for about an hour and came back and I was like, what? How can I be burnt? It's crazy. So it goes to show you how much I've been out and about. Not a lot. I need to get out more. All right, so 6.6, we're talking about solving exponential equations. And there's kind of this little property that you need to understand when we're solving these exponential equations. And so it says if a to the n power equals a to the m power, then n equals m, right? So meaning if we had something like a to the x power equals a to the second power, well, then x must be 2, right? Then x equals 2. So this is kind of what we're going to be using. But in order to use this property, notice that our bases have to be the same, right? It's base raised to a power, same base raised to a different power, right? But we've got to get those bases to be the same if they're not the same, so we can figure out what the exponent is. All right, so that's going to be kind of what we're going to talk about on this one. So let's do some examples here. So for example 1, we're going to solve 3 to the x power equals 27. All right, so trying to follow this property up here, we're trying to get it so that our bases are the same. Well, we can see our base on this is 3, so we're thinking 3 to the x power equals, and then you want to see, could you get this 27 as base 3? So you're trying to think to yourself, you know what, let me write it this way, like if I have so is there like what times, you know, so 3 times 3 times 3 gives us 27, right? So we're trying to think, we need this base to be a 3, but we're trying to figure out what power that's going to be, right? So 3 to the third power is 27. So since my bases are the same, right, they're both 3's now I can just set my exponents equal to each other, and x equals 3 is my answer. Okay, so sometimes they're pretty straightforward like this and maybe easier to see, you know, just trying to think, okay, how can I make the base of, you know, so 27 into something that has a base of 3. All right, let's try another one so kind of get an idea what we're doing here. Example 2. This time let's solve 2 to the x plus 1 power equals 8. All right, so again, we're trying to write this so that they have the same bases. Right now we have a base of 2 and a base of 8. So you need to rewrite it. So you're trying to think to yourself, you know, is there a way that I can multiply, you know, base of 2 together, right? So 2 to the what power gives me 8. And what is that? 2 to the what power?
2 to the third power?
Yeah, 2 to the third power. So let's rewrite that in. We're going to replace that 8 with 2 to the third power. So I have 2 to the x plus 1 equals 2 to the third. All right, so now that my bases are the same, I can set my exponents equal to each other. Right, so my x plus 1 equals 3. And then I just need to solve for x here. So I'll just subtract 1 on both sides. So x equals 2 would be my answer on that one. All right, what can I clarify for you on those first two examples?
Will the numbers kind of always be that easy to find what their root is?
Not always, and I'll show you a way if you can't figure that out, what we'll do. So there's another way to solve them if you can't get them so the bases are the same. Good question. All right, but usually, a lot of times they will be this way, where you'll be able to get them the same. Okay, let's look at example 3. Again, we're going to solve, trying to figure out what x is. This time we have 5 to the 6x plus 10 power equals 25 to the x minus 1 power. Okay, now our base is the same on this?
No.
How could we get them so they are the same? Anybody have an idea?
Isn't 5 to the second power 25?
Yeah. So 5 to the second power is 25. So look at what we need to do with this, right? So we'll leave the left side just the same. Right? That one's not changing, but 25, we're changing to 5 to the second power. But then we still have this x minus 1 up there that needs to be multiplied by it. Okay, so we change that to 5 to the second. So then we're really doing 2 times that x plus 1. Okay, but now our bases are the same. So now we can set those exponents equal to each other. Right? We couldn't do it on this top one until we change that 25 into 5 to the something power. So our bases are the same. All right, so then we have 6x plus 10 equals 2 times x minus 1. So 6x plus 10 equals, let's distribute that 2 through, 2x minus 2. Let's get our x's on one side and our numbers on the other. So I'm going to subtract my 2x over. Because 4x plus 10 equals negative 2. And then I'm going to subtract my 10 over. All right, just solving these equations like we've done a lot of times before, right? And then divide by 4. So in this, x equals negative 3. So I want to talk about like doing a check on this. Right? So what if you wanted to check the, to see if you got the right answer? Is x really negative 3? Well, let's put negative 3 in place of x, right? So put negative 3. Ah, what happened? Whoa. Oh my goodness. Hold up. Something weird's happening. I don't have any idea what that is. All right, so put negative 3 in place of x. I should say of all x's, right? Because x shows up in a few different places, right? And it doesn't matter if you use this top one or the bottom one. I'd probably prefer to use the bottom one because then you can just see, are the exponents the same, right? So if I did 5 to the 6 times negative 3 plus 10 power, does that equal 5 to the 2 times negative 3 minus 1? Right? So if I look at my exponent here, that's really saying, so I have 5 to the negative 18 plus 10 power. And so that's really going to be 5 to the negative 8 power. Right? When I simplify that, let's go do the rest over here. 5 to the 2 times negative 4 power. And multiply those together, I get 5 to the negative 8. So I do get the same thing. All right? 5 to the negative 8 equals 5 to the negative 8. So for sure, this is my answer. All right, so just make sure you're keeping in mind, whenever it says solve, you can always check your answers and make sure that you have those correct. All right, so there's no need to miss any of those on tests. Anything, you can do this. All right, let's look at another one. And on this next one, it's going to be kind of what I think it was Elizabeth that was asking about. All right, so this one we're saying 2 to the what power equals 10. Well, if I try and figure out, 2 to the what power equals 10, right, and I keep raising it to different powers, right, well, we know that, 2 to the third power is 8, and then we know 2 to the fourth power is 16. So we know this is going to have to be between 3 and 4. Our exponent is going to be some number between 3 and 4. But how do we figure out what that is, right? So this is what we're going to do. So remember how I said that exponentials and logs are inverses of each other, so they undo each other, right? So exponentials and logs undo each other, right? They're opposites, right? They're inverses of each other, of each other's. All right, so what does that mean? Well, I can do something here to help me figure out what I'm going to, how to solve this. So in order to solve this, I need to take the log of both sides, because if I take the log, I'm going to be able to solve for this x. Okay, so what should I do here? And it actually doesn't matter whether you take the log or the natural log, just as long as you do the same thing on both sides. Okay, so I'm going to take the log of this side and the log of this side. All right, whatever I do to one side of the equation, I have to do to the other. Okay, then there's a property of logs that says if I have an exponent, right, in a log, I can bring that out front to be multiplied by it. So meaning this now looks like x is out in front times log of 2 equals log of 10. Okay, and then to solve for x, well, it's connected by multiplication, so I just need to divide both sides by the log of 2. Right? And sometimes it might ask you to keep your answer in exact form, and so make sure that you write this down, because on your homework it asks for 2 different forms. I want you to put your answer in exact form and approximate to a certain decimal place. So in this one, the exact form is just log of 10 over log of 2. Right? That would be your exact answer. Okay? Or the other way, it might want you to approximate it. Right? To, let's say, 4 decimal places. All right, so then you're going to put this into your calculator, so I want to make sure that you practice how to do that. So put log of 10 divided by log of 2. Now, in your calculator, sometimes you guys are going to have to put parentheses around both of these before you divide, or press, do log of 10, and then press equals, and then your divide button, log of 2, and then equals. All right, so I want everybody to try it right now and see if you can figure out what that approximate is. Okay, so you should have something. The approximate's going to be x is approximately 3.322. Right. Oh, wait a minute. Sorry, I wanted to go one more place. 3.3. Oh, I guess it's just going to be 19. Sorry. So 3.3. Sorry, I'm having a hard time seeing my calculator screen. Okay, so we go to 4 decimal places. All right, that would be our approximated answer. Questions on how you get there? Were you able to get there? And I want you to try one other thing, because this is like, some people, they get this question all the time, like, how do I know if I need to take the log of both sides or the natural log of both sides? Well, I want you to try it. If you try the natural log of 10 divided by the natural log of 2, as long as you're doing the same thing, right, to top and bottom, it's not going to matter. You're still going to get 3.3219. Right? So it doesn't matter, but you got to keep it consistent. Whatever you do to one side, you got to do to the other. All right? If you take the natural log of one side, you got to take the natural log of the other side. Okay? All right, let's try another one like that, because these ones are a little bit trickier, right? So if this is what you're going to do if you can't figure out, right? We couldn't figure out 2 to the what power was 10, right? Well, we know now that 2 to the 3.3219 blah, blah, blah power, right? And we knew it was going to be between 3 and 4, which this answer is. Right, that's the power that you're raising to get 10. All right, let's try another one. Example 4. Okay, so let's do 2. So again, we're solving. 2 to the 3x minus 1 power. Right, so 3x minus 1 is the exponent. Equals 7. So again, 2, can't write, 2, we're thinking 2 to the what power equals 7. All right, well, I know 2 to the second power is 4, and 2 to the third power is 8. So we know it's going to be somewhere in between 2 and 3. Right, but in order to undo this, right, we've got to take the log of both sides. So I'm going to take the log of this side and the log of this side. And remember, by doing that, that whole exponent, right, is going to come out in front and be multiplied by the log of 2. All right, so let me show you what that looks like. So out in front is this 3x minus 1. Put it in parentheses, because this whole thing is being multiplied by log of 2. Okay? And then on the other side, we have log of 7. Well, okay, so now we're trying to solve for x, right? Maybe I'll be more specific here. Solve for x. Well, we're trying to get x by itself. It's connected, right? This 3x minus 1 is connected to this log 2 by multiplication. So let's start by dividing the log of 2 over. Right? Then that's going to give us this 3x minus 1 equals log of 7 divided by log of 2. Right? And so on this one, it's probably going to be easiest if you just do some decimal approximations rather than finding the exact answer. You can, but let's just say on this one, let's round to just say nearest tenth on this one. Okay, round to the nearest tenth. So with this, right, so in your calculator, figure out what log of 7 divided by log of 2 is. But you've got to keep that number in your calculator, right? Don't try and rewrite it in there. So let me put it in here and show you what I mean. So if I have log of 7 divided by log of 2, and it's going to give me this 2.807, right? But it doesn't stop there. So you can't just, you can't put all these digits in there. You've got to keep this in your calculator, just like it is. Okay? And then to get x by itself, next thing we'd want to do is add 1, right? So keep that number in your calculator, press +1, right? Then we get 3x equals 3.80735, blah, 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 right? It keeps going and going and going. Keep that number in there. right? Don't take it out and re-put it back in. Otherwise, you're going to get your answer off by a little bit. Okay, and then to get x by itself, now we need to divide by 3 on both sides. So in your calculator, press divide by 3. And so I got approximately, right, 1.3 if I'm rounding to the nearest tenth. It came out to be like 1.269118307, and on and on and on. Okay. Okay, so that one has a lot to it. So let me answer what questions you have there. Is there a place where you got stuck? Why are we taking the log of both sides from both, or at the beginning? Can somebody say that?
Is it to get the x by itself?
Yeah. Yeah, we got to take that exponent. That's the only way that we can get that exponent out in front so that we can solve for x. Right? That's the only way we can do it. That's why we have to solve or take the log of both sides. Okay. And then notice that after we did that, we divided both sides by log of 2. Right? Change that to a decimal. Add the 1 over. Keep that all in your calculator. Divide by 3. Right. Okay. You guys doing all right with it? It's really so hard for me to tell. I want to know that you guys are doing okay. You know, sometimes this log stuff, it's just so new to so many people that they're just like, I'm not sure. Some people are like, I'm so lost, I don't even know what question to ask Becky. So if you're in that boat, just say, Becky, I'm so lost, I don't even know what to ask.
This surprisingly all makes sense to me.
Yay! See, this is what I need to hear. Just need people to speak up and say, okay, I'm getting it. I'm getting it. Or if you're not, speak up and say that too, because other people are going to getting stuck at the same point you are.
Yeah,
So,
first is definitely looking like really intimidating, but
yeah,
it's just a lot of steps.
it is. Yep, it's a lot of steps, but once you kind of get the idea, like you're so used to solving for x, like we've done that so many times. Now it's just throwing one other thing in it, right? Take the log of both sides first, but still doing the same things. You're trying to get x by itself. Okay. All right, let's see. I think we're going to do one more here with the natural log. So when you have a base of e, like this one I'm starting off with, then you have to take the natural log of both sides on it. Okay, so you've got to, let's see, so example 5, show you what I mean.
So my calculator only has the natural log button. It has the e to the power, but it doesn't have like just a straight up log button. So
It
is
should.
okay if I do natural all the time?
It should have it. What calculator do you have?
A TI 36X Pro is what
Yeah,
it says.
it definitely has it. Let's see, Jordan, did you say you have that same calculator?
I have the TI-30X.
You have the TI-30.
So I don't know if it's different.
Yeah, it is a little
But I
different.
think the Pro will have it. It's supposed to be a better one.
Yeah, so it's usually either just right above or right below or like to the side of it. Like they're always really close to each other. Oh, you know what? I remember on that one now. Look on it, you actually have to hit it twice. So on your calculator, it'll say like natural log / log.
Oh!
And so if you hit that button twice, right, so once it'll take you to this, twice it'll take you to that. I was trying to remember. I was like, I'm not familiar with all the calculators, but does that make sense?
Yeah, it says IN log, and when I double hit it, it did the log. And
Yeah.
when I hit it once, it just does the natural log. So
Yep.
I just thought it meant that it's saying the natural log right there.
Yeah. Yep.
Okay,
Yep. So just
thanks,
hit it
guys.
twice. No, that is like a really tricky thing on that calculator. So I'm glad you spoke up. So anybody else that has that TI 36 something Pro, 36X Pro or something, Make sure you know how to get to that because that is trickier on that one. Okay, let's do one more here. I think we might stop for the day. I know you guys have kind of, your brains have been spent, I'm sure. These are a lot of steps to remember, but I just hope you're really getting it. Okay, so notice on this one, right, our base is E, where our other ones weren't before, right? We had a base of 2, and, you know, and so it didn't matter whether we did the natural log or the common log. But when you have a base of E, you must use the natural log, okay? So I'm going to put that over here. So when you solve an exponential with a base E, okay, you must use natural log to undo it. Okay, so on this one, right, again, we're trying to, you know, figure out what x is, right? But in order to get this 4x out in front, I have to take the natural log of both sides, right? And then remember, now, since I'm taking the log, that now there's a property that says I can bring that out in front, but that's only with logs. That's why I have to do it. So now it's going to look like 4x, right, times the natural log of E equals the natural log of 17. Okay, now I want you first of all, because this is one of the things I said before, we were going to come back to this idea. I want you to put into your calculator natural log of E. What is the natural log of E? Let's figure out how to put it in there. So you kind of have to, it's a little bit tricky. So you have to hit your natural log button, and then you might have to do E to the first power on some of those. Anybody get that? This is a really important one to understand. What is the natural log of E? So like I said, in your calculator, you might need to put natural log of E to the first power. That's how it might look. Come on, I know somebody's got it.
Is it just 1?
It is. It is just 1. And so this is something that I want you to memorize, or, you know, make sure you star, know, because look at how much easier this is going to be to solve this. So if we know that natural log of E is 1, right, then I'm just going to replace that natural log of E with 1. So it really says 4x times 1, right, equals the natural log of 17. Well, now all that we have left to do, right, to get x by itself, because this is just a 1, all we need to do is divide by 4. And notice this time you're not dividing by the natural log of 4, you're just dividing by 4, right? So it will help you a lot if you can remember the natural log of E is 1. That's going to show up in a lot of different problems. Just change that. Whenever you see natural log of E, change it to 1, right? In fact, I'll just kind of go like this, right? So it basically goes away there. And so then, right, in your calculator, right, do the natural log of 17 divided by 4. And what do you come up with there?
We need decimal places.
Yeah, let's go to 4 decimals again.
4? Okay.
Yeah. Okay, so you guys got 0.7083. All right, if you didn't get that, check to make sure. Did you accidentally divide by natural log of 4 instead of 4? Just because that's what we were doing before, right? We had to divide by the log first, but it was so awesome on this that our natural log of e is just 1, so we don't even have to do anything with that. All right, and so all we were doing is dividing by 4. Okay, so this is basically saying, you know, if we were to check it, right, so remember you can check these, right, to check it, go back to this original equation. So we're saying e to the 4 times 0.7083 power is going to equal something pretty close to 17. Right, so multiply those two numbers together first, then raise e to that power. Or some of your calculators, you can put that all in, just like it is there. And you'll see it's going to be something close to 17. Let's see what it does come out to be. So anybody have it?
I got 16.999777315.
That sounds pretty close to 17 to me, right? So that looks good. So you're going to have, right? And remember, the whole reason why you can't get there exactly is because we're rounding this number, right? If we put out all the digits, you know, I mean, I guess even if we took it out 10 or 12 places, we'd probably be able to get to, you know, 17, you know, at least really, really close. But that's why, you know, because we're not putting all those decimal places out because we can't write all of those out. So, but that's why. Okay, so that checks out. So we've got that 16.9, was it 9999? Yeah, right? And that's close enough, right? All right. Any questions on that one I can answer for you? All right, well, it looks like we'll be finishing up a few minutes early here, but if some of you have some individual questions and you want to stay on, if it's, you know, anything to do with homework or just anything from our lesson that maybe you want to do another, you know, work another example with, you can. Otherwise, I will see you guys on Thursday. Okay, have a great day.
Bye, Becky. Have a good one.
Bye. Thanks so much. You too.